coordinate, we always write the x coordinate first. X coordinate is -3, y coordinate is -5. So any point, like this is x, this is y, just place it in this formula in place of y and x. You can place it in this formula, right? We can, it depends on the kind of question that we get. We do all different types of questions, then you'll get it. We can use this to solve this equation as well. Okay, now parallel and perpendicular lines. This is a very important concept which confuses a lot of students. Parallel lines have the same angle. So for example, this line and this line, they are parallel. Or if you have different lines, for example, this line and this line, they are parallel, right? They must have the same angle. Like this. These two are parallel. Yes, Kirat knows. Hamdan, we can revise these concepts tomorrow as well, but we need to complete the concept so that we can start implementing them. So the concept is parallel lines have the same gradient. Parallel lines, gradient is the slope. Parallel lines have the same gradient. Yes, Amal knows for perpendicular lines as well. So for example, if we have been given like this is a line and this is a line, both are parallel, m of this line, m means gradient, is 2. Then m of this line is also 2. Parallel lines have the same gradient. If you know the gradient of one line, its parallel line would have the same gradient. Gradient is the slope. You can see the slope is same for both. If you have two horizontal lines, both have a slope of 0. Gradient is 0. Parallel lines. If you have vertical lines, gradient is maximum. They are parallel. So if you know the gradient of one line, you also know the gradient of the other parallel line, which would be the same. No. The reference points are different. So this is starting at this point, ending at this point. This is starting at this point and ending at this point. Gradient is just the slope. It doesn't matter if you start from like here to here, as long as they are parallel. Gradient is just the slope. Your starting and ending values can be different. You can still get the same slope. Yeah, the inclination is the exact same. The angle of inclination is the same. Is this parallel lines concept clear to everyone? Yeah, gradient is steepness. Is there anyone who does not understand parallel line concept? Parallel lines would have the same gradient always. Now perpendicular lines, gradient is harder. Gradient of perpendicular lines, gradient of perpendicular lines, perpendicular means 90 degrees to each other, is negative reciprocal. I'll just write it in inverted commas. Is negative reciprocal. Okay, now this term would make more sense when we implement it in a few examples. Reciprocal is like, for example, we have 3 by 2. Its reciprocal would be just to switch the numerator and denominator. So the reciprocal would be 2 by 3. Negative means change the sign, right? So if we have 5 by 2, its reciprocal would be 2 by 5, right? I'll explain. Okay, so if you have been given the gradient of one line, so let's suppose the gradient of this line is m is equal to 5, let's say. M is equal to 5. This is basically 5 by 1. If there is nothing written in the denominator, it means there is 1 there. Now this particular line, which we can see is 19 degrees to it, perpendicular to it, its gradient would be negative reciprocal. Negative means you change the sign. This is positive 5 by 1, so you change the sign. This would be negative. And this would be 1 by 5. Reciprocal means swap the numerator and denominators. So the gradient of this line would be negative 1 by 5. So you just change its sign and you swap the numerator and denominator. That is what negative reciprocal means. Now, as we discussed earlier, a line sloping upwards is positive, right? And a line sloping downwards is negative. So you can see this is sloping upwards, so positive. 90 degrees to it, perpendicular, is sloping downward. So that is why it has a negative gradient. Right? So just remember, change the sign, take reciprocal. That's it. For perpendicular lines, change sign, take reciprocal. We'll do a few examples and we'll see if you guys understand it. Okay, now I'm taking a different value. The gradient of this line, sure Hamdan, the gradient of this line is positive 3 by 5. What's the gradient of the perpendicular line? What would be the gradient here? Change the sign. That was positive. This would be negative. Take reciprocal. 5 by 3. This was 3 by 5. This becomes 5 by 3. That's it. Is this term negative reciprocal clear, guys? Okay, now let's suppose these are parallel lines. The gradient here is negative 2 by 7. What's the gradient of this line which is parallel to it? What's the gradient of this line? These are parallel lines. These are parallel lines. The other one was perpendicular. Parallel lines have the same gradient. I was discussing about these parallel lines. So the gradient would be the same, minus 2 by 7. Right? So do you understand the concept of parallel and perpendicular? Parallel lines, same gradient. Perpendicular lines, negative reciprocal. Change the sign, take reciprocal. Just swap the numerator and denominator. Any doubts here? Any doubts? Okay, let's just quickly. Now you see, these are all parallel lines. Yes, a fraction always has a collective sign. So for example, if I have minus 2 by 3 or minus 2 by 7, this minus is with the whole thing. This minus is with the whole thing, this whole thing, right? Okay, now, so two or more straight lines, they are parallel. They have the same gradient, as you can see. These are all parallel lines. If you find the gradient of this line, and this line, the gradient is exactly the same. Our equation is y is equal to mx plus c. Y is equal to mx plus c. What do we notice here? All the gradients are same. 2, 2, 2. All the gradients are same because these are parallel lines. But y-intercept are different. The first line, it crosses the y-axis at 5. You can see plus 5 here, positive 5. The second line, it crosses the y-axis at plus 1. So plus 1 here. This last line, this crosses the y-axis at negative 3. So negative 3. So y-intercepts are different. But what we notice here is for parallel lines, the gradients are exactly the same. The gradients are exactly the same. So parallel lines, same gradient. Okay. Now perpendicular lines. You can see this line, if you know the gradient of this line, what's the gradient here? M is equal to plus 2. Its perpendicular line would have just change the sign. Plus 2 plus becomes minus. Take reciprocal. This is 2 by 1.